Assalamualaikum and hi everyone. My name is Nuradia binti Muhammad Ridwan. I am from section 2. My metric number is B04191040. I am from group 13. My team and I will explain on how to find the line integrals over piecewise smooth curve and one application question. So let's begin. Okay, let's move on to the question. Let C consists of a line at point -2, -1, 2, point 0, -1, then a part of cubic graph which is y equals to x cubed minus 1 at point 0, -1, and a line at 1, 0 to 1, 2. Evaluate the integral of 4x cubed ds. So this is how the graph will look like. So stated that line at point -2, -1, which is here, and then 2 point of 0, -1 here. For C1, y equals to -1. Then for C2, we have a part of cubic graph which is y equals to x cubed minus 1 at point of 0, -1 to point of 1, 0. Then at C3, we will have x equal to 1, which the line occurred at point 1, 0 until 1, 2.
Assalamualaikum and hi, my name is Wasita binti Rosli, number matrix B0419101145. So before this, my friends Radia already show you on how to sketch a picture of the curve in question. So this is the question and the curve of the sketch of the picture C1, C2, C3. So first and foremost, with regard to what we're doing up here, what we do is break C equal to C1 plus the curve of C2. As you can see, the C1 and plus the line C3. So as far as C1 is concerned, because it's the line segment we use, the same parameterization, and say that this is going to be x equal to t, y equal to -1, and the automatic parameterization that goes into this is that t is then equal -2 and less than equal to 0. Now you will notice that if we plug in t equals -2, we will get x is equal to -2 and y is -1. That will take us from our initial point. So this is our initial point, -2, -1. So at t equals to 0, so this is point 0, -1 for our terminal point. That works out well. So from this parameterization, I will show you the formula. CFS minus y ds equal to C1 fs y ds plus C2 ds plus integrate C3 x y ds. So I will show you from my part for C1. So for the C1, x3 ds equal to C1 for x3 ds. Okay, from this is not the x, not the y, so not individually respect to integration smooth curve to the s. S is a length which s cannot directly use apply before. So the line integral of fxy along c with respect to arc length, we use this formula s equal to ab dy, sorry, no, not this, s ab dx over dt square plus dy over dt square, and don't forget dt and square root. Okay, and then we apply this formula equal stat A. We will use this range of parameterization. So this is minus 2, 0, 4. So for x we get t cube, and for dx over dt, so differentiate with this, x prime we got 1, y prime 0. So dx dt, x prime we got 1 square plus dy dt, y prime 0 square, square root dt. Okay, and then we simplify this, we got 1, so minus 2, 0 for t cube dt. So integrate this, so integrate for t cube, so t 3 plus 1, 4 over 4, so this 1, 0 minus 2, and then solve it. T0 power of 4 minus negative 1 into t, so minus 2 power of 4 and we got minus 16. So this is it. Therefore our C1 is minus 16. Okay, for the next step I will pass to Haja. Thank you.
Next, I will show you how to find curve C2. First step, we need to parameterize the curve C2 first, which is we get x equals to t, y equals to t cube minus 1. So the range is between 0 until 1. Next, step 2, we write the formula given, which is we use the formula of line integral of f respective to the arc length that I show in the video. Next, step 3 is we insert the parameterized value into the formula given, and we get from the range 0 until 1 for t power of 3 times cert 1 power of 2 plus 3t power of 2 dt, and we get 4t power 3 cert 1 plus 9t power of 4 dt. Next, step 4 is we use substitution method to integrate, which is we let u equals to 1 plus 9t power of 4. So we differentiate it, we get 36t power of 3, and we arrange the formula du over 36 equal to t power of 3 dt. Next, step 5 is we insert the value of the substitution method inside the equation to integrate, and we integrate it to the respective u, and we get 2 over 27 times 10 to the power of 3 over 2 minus 1, and we get the value for the C2 is 2.268. Okay, that's all from me. Thank you.
Hi, my name is Hanani Shahira binti Muhammad Khairuddin, and I am from the MC section 3. Okay, so I am going to solve for the C3 part. So let's solve it. The integration for C3 and function is 4x cubed ds is equal to the limit from 0 to 2, refer to this, 0 to 2. Since we have the value for the x is a constant, then we just direct substitute the value in the x. And then for the x, we have the derivative for 1 is 0 plus derivative for t is 1 dt. So let's solve it. 4 times with 1 cube is 4. 0 to the power of 2 is 0, plus 1 to the power of 2 is 1, and square root of 1 is 1. So that's mean times 1 dt. 4 to with respect of t is 4t, with the limit from 0 to 2. And then we substitute the value of t with 2 minus 4. The value of t is equal to 0. And then we get the answer for it is 8. Okay, so finally, the line integral that we were asked to compute is equal to the function for 4x cubed ds with the summation of the integration of c1 plus c2 plus c3. So for the value for integration of c1 is negative 16, plus with the value c2 is 2.268, plus with the value for c3 is 8, and we got the final answer is negative 5.032. So this is the final answer.
Okay, this is the application of line integrals question. So the question is, find the mass of a wire lying along the arc of the circle x squared plus y squared equals to 1 from A 1 0 to B 0 1 with the density of xy here. So this is the solution for the graph. We will have a circle of radius 1 starting from point A 1 0 to point B 0 1 is the arc length that we will find the mass of the wire. So we know that x equals to cos t and y equals to sin t, and the interval here or we call limit is 0 to pi over 2. Why we call it 0 to pi over 2? Because this is the first quadrant. So first quadrant here 0 until pi over 2, and this is pi, this is 3 over 2 pi, and this is coming back here is 2 pi. And then for the formula of mass of wire, we will have m equal to the limit alpha to beta, then we have the density here, this is dot product with set dx over dt squared plus dy over dt squared dt. So this is the limit we have before, 0 to pi over 2, and then this is the value of density, and then this is the formula. And then we know that x equals to cos t, and then y equal to sin t, and then we substitute in here, and then this one also we substitute with cos t, and this one is sin t. Then we settle this part here. We will get, when we differentiate the cos t, we will have the negative sin t squared plus cos t squared dt. So as we know that when we square each of the value here, we will have sin squared t plus cos squared t. Then we will use the trigonometric identities, which is sin squared x plus cos squared x equals to 1. Since we use the variable here is t, so sin squared t plus cos squared t equals to 1. Then here before we have set 1, and then we will have 1. That's why the 1 is times with the cos t sin t dt here. But the cos t sin t dt here, the value of cos t sin t, we can have the value from the trigonometry identities too, which is when we take from sin 2x equals to 2 sin x cos x, then we rewrite as sin x cos x equal to 1 over 2 sin 2x. And here this is for our solution, with which we use the value of t as our variable. Then we'll integrate here. We move out the only constant here, 0 pi over 2 sin 2t dt. Then we integrate here, we'll have negative cos 2t. This is the value over 2, and then pi over 2 0. Then when we integrate, we will have 1 over 4 times 2 here, negative cos 2t, and then substitute the value of pi over 2 and 0 in here. Then when we calculate with the calculator, make sure we use the radian mode for calculator, so because we have the pi value here, and then we will get the final answer is 1 over 2. And that's how we find the mass of the wire.